All right. Hello there. Oh, that is loud. Hi, I'm Láznička. I am a former Red Hatter. Nowadays, I'm working for Microsoft. I'm doing Kubernetes open source. And today, I will be talking to you about Kubernetes multi-tenancy in image pool. Before we start, I should probably explain what a tenant is. Maybe not all of you know. I know that certainly, you know, I've known it for a very long time in my career. And so when we're talking about a tenant, we're talking about an organizational unit which usually shares some kind of permissions and privileges, and that can be scoped within the unit. So, for example, you can have like a tenant can be like a company in a system that that functions between multiple companies, or it can also be just a user in a system that is multi-user. So yeah, just so that we get a lingo synced. All right, we will start with a story. It's a technical story. It's not a fairy tale or anything, more like a horror story, really. So imagine you've got a private container image. Let's call it a cool stuff private, v1. And this is a private image container, right? And so it lives in some kind of a private repository called containerrepo.org/niceorg, which requires some additional authentication so that you can get your private image, right? And since you've got a container image, you may want to run it in Kubernetes. In order to do it, for a private container or private container image, you may know that in order to pull from a private repository, you need to add your credentials inside a secret, and you would then reference this secret inside of your pod manifest, right? And so kubelet will eventually take that secret and authenticate the image, right? And for our case, we are running a workload in a namespace, niceorg ns, and only the people from nice.org can access anything that's inside of this namespace, right? So nice.org is some kind of a tenant, right? But for some reason, it appears that people from not so nice.org got their hands on the secret information that was inside of your private image. But how could that be? They do not have access to your namespace. They do not have access to your container repository, right? Because they don't know what the credentials would be. So how did they get their hands on the secret that was inside of your image? Well, to understand this, I've got a little picture here to explain that situation to you. So, like I said, you have a pod A, which is linking some kind of secret one, and it is requesting an image with a if not present image pool policy, and it adds. Does this have a pointer? Never mind. It adds a secret one to the request, right? To the kubelet. The kubelet sees that request. It sees that the image is not present, and it via a container runtime it issues a pull request for the image, and it adds the credentials from the secret that you added originally, right? The image is pulled. The kubelet sees it. It's actually stored locally on the node. And the kubelet is then able to run your container in Kubernetes. But then a pod B comes, and it doesn't add any secret or anything. It just says, I want this image. Oh, I don't have any credentials whatsoever. Can you please give me this image? And it just so happens that it actually goes to the kubelet, and the kubelet sees this request and says, okay, do I have an image called this in my in the local store? It asks the container runtime. The container runtime says, yes, do you want it? Kubelet says, yes, absolutely. Let's go ahead. And this is what happened, right? While the pod A needed some credentials to actually access the image, the pod B did not. And I mean, at this point, you might be thinking, hey, that's not right. I don't want this to happen in my cluster, right? And I agree, this is not great. The good thing is that even today, you are able to mitigate the situation to some degree what people do most of the time, and OpenShift does that if you're from Red Hat, is that they use the Kubernetes admission controller, which just turns whatever you've got in image pool policy to always pull, which means that the kubelet will always attempt pull. The good thing about that is that it's not that the full image is getting pulled all the time, but if the image is already present on the node, it's just the manifest. So this is not terrible, right? But it adds that one request to the image repository, and that can be troublesome if if a couple situations happen at the same time, right? Let's think like what happens if the repository is down and all of a sudden you decide that you want to kill all the pods for your deployment and start a new rollout, right? You immediately get an outage because the repository is unable to say, yes, you can pull this image, or no, you cannot, because you just cannot reach the image registry, right? And so the situation has been like this in Kubernetes for a very long time, and we finally decided that maybe we can try to have some of the best of both worlds, right? We want the access to the on-node images to be somehow going through some kind of authorization. But we also don't want them, we don't want every image request to be going to the repository, just for cases when the repository is down, right? And that's what I'll be talking about today. And in the couple next slides, I will be kind of involving you in the thought process that we have. I'll show you the problem space. So what I would like you to do is maybe, look at the problems that are out there. Think about how would you solve all of this, and then in the end I will show you how we solved it, and you can see maybe would you do it this way, would you do it differently? Yeah. So let's have some kind of a creative process. All right. So to understand all of that, we actually already kind of talked about this, the structure of an image pool, right? But this slide I've got here just so that we kind of understand the components that we've got here, right? We've got kubelet, which is trying to act on behalf of the pod, and it is trying to interact with some kind of container runtime using container runtime interface. And these are two separate components, right? And unfortunately, as you can see, in point 5 here, when the container runtime actually manages to pull the image, it doesn't save the information about the credentials that were used to pull that image anywhere, right? And that's basically where all of these problems are coming from, right? Because then kubelet has no way to know, okay, this was the user, it's fine if this next user is, or this next set of credentials that I'm getting can access this image, right? And so you can see we've got some async components, right? We've got kubelet, and we've got container runtime, and they don't necessarily share the information that we want, right? The kubelet doesn't get user information from the container runtime interface anyhow, or from the container runtime. And so we need to build a cache. And caches are great, right? Nothing can ever go wrong with a cache. And so, yeah, we're building a cache that will create a mapping of a user, or maybe a set of credentials to be specific, to some kind of an image, right? But what we also like to do, we don't want to lose all this information, because we want to make sure that we are still reaching out to the external image registry the least, and so we would ideally want to keep this cache somehow persistent, right? And so we will probably use some kind of persistence, either files or database or whatever. All right. There's more trouble though. So you're thinking about the cache, right? You're writing the records in there. But since we've got two async components, we've got a kubelet which issues a pull request or request for image pull to container runtime. But if the kubelet crashes somewhere through the process, the container runtime doesn't care. It just pulls its image, stores it, and then when the kubelet starts up again, it sees, oh, there's an image already pulled. Cool. I can probably use that. I don't have any information about it, so must be good or must not be. We'll see why this could be troublesome. Even like, you know, when we don't have any information about it, like why it could be troublesome in a little bit. But yeah, for now, just remember that this would be a CVE probably. And so, now that we know that kubelet, you know, could crash, like we don't necessarily care about the container runtime crashing because we would know that something went wrong, right? But if kubelet crashes, when should we write the record then? Like, should we write it before we actually pull the image? But then in that case, you know, we would have a record of the image being pulled with some kind of credentials. But if the authentication fails, kubelet crashes, that record is kept, right? And so we would have an unauthorized request that would actually be able to use the private image. And so would we be writing the record after the pull? What would that mean? What happens when we crash somewhere halfway? We would actually have an image which is some kind of, is unattributed, right? We don't know what happened or what didn't happen. And you may say, well, that's okay. We can always try again, right? Well, there's trouble because different people are using images differently, right? And so we want some kind of feature flexibility for more fun with the cache, right? So there are use cases where Kubernetes actually lets you pre-pull the images to your node so that this image can be then used by any workload immediately, right? Like you want that image to be available by anyone running there. And so maybe it's a good idea to kind of keep this use case for, you know, like either for like images that you really need, like you are running your own control plane for a different application, right? And so you've got a set of nodes where you want to be able to always like access these images like unconditionally. Or maybe sometimes it can be just like that the access to those images is fairly impractical, right? Meaning maybe your Kubernetes cluster is in some kind of an airtight environment and cannot always pull like from all of the registries that you may want. So that's the first use case, right? And this is why you would have trouble when you see an image that is already pulled onto the node and basically like what do you do then? You don't have any record, so that probably means that it's meant to be used by anyone, right? But it's not really. Then you've got a different use case, which is kind of similar to the first one, where you've got a set of images that should be removed from the pull authentication, right? This is for platforms that run their own control plane in pods, meaning like you've got a kube API server in a pod, you've got a kube control manager in a pod, which anyone here is from Kubernetes, from OpenShift, you may know that you're actually doing that. And this is just a more explicit case of one, right? Like these are the images that I know are fine, so just use those without authentication. Or you may think, you know, it's all right, just always verify. And in that case, like you wouldn't care about unattributed images because you would just go through the whole process again. And then, of course, like you can go YOLO and say, the current behavior is fine now. I'm good with that. Let's just keep that. But that's, I don't think many people will like that. Either way, even with the fourth case, you know, you still have to think about, so what happens if I'm going YOLO and then I want to always verify, right? That means that you may want to keep, or maybe not necessarily like always verify, but like the first case, which would mean you need to keep your records in your cache, just in case like there is a policy switch, because anybody can change their opinion eventually, right? And so right now you probably have something in your heads, like some way we would sort it out. I have a solution for you, solution that we came up with, and it may look simple, it took quite some time, but anyway, we've got these new, from the higher level, we've got these new two fields in kubelet configuration. The first one is called image pool credentials verification policy, like rolls of the tongue, which lets you set 4 different policies, right? And then we've got another beautifully named configuration field, which is called preloaded images verification allow list, which is only usable in the second case, if you remember it, like where you explicitly set the images that you don't want to ever be going through credential verification. What we are also doing is we are actually writing records before and after an image pool, right? And this way we are kind of tackling the problem of kubelet crashes somewhere in the middle, and either we would be missing a record or we would have one extra. Of course, like in each of the stages, you have different kind of information, and so you need to deal with that. And of course, that means that the records look a little different. I'll show you in a little bit. But yeah, this is basically what we do. And so the cache nowadays lives on disk. We will be adding an in-memory layer. That doesn't mean like it will be only in memory, but the records will still be written to the file system somehow. But we will just add some caching to improve the performance a little bit. And today we've got this val-lib kubelet, which is just like a root kubelet directory. And then we've got a new directory called image manager, and this image manager directory has 2 subdirectories, pull in and pulled, each for different kind of records. And file names that appear in these directories are SHA-2 hashes of either the image name for the image pool intents or a hash of the CRI references, just so that we tackle the problem of maybe somebody trying to do some weird things like directory traversal or just weird characters appearing in the file names, which can be sometimes probably interpreted by the operating system differently than we would want. All right, so the persistent records. We've got image pool indent records. These are the records that are written before the actual pool happens. They don't store too much information because we don't actually have too much information. We just know that we want to pull an image, right? And so we just store the image name from the pod spec. And these get removed as the pool is actually processed and finishes either properly or improperly, right? Or like either it errors out or it's successful. And when it's successful, we actually write a different kind of record, which we call an image pooled record. And this record actually has much more information. It stores information about like the CRI, like the reference that we got from the CRI, about how to access the image in the system, and it also stores the way how the image was pulled, right? Like either node accessible creds, that also means like anonymous pull is the same, right? Like anybody on the node is able to either pull it from the with the credentials that are available on the node, or anonymous pull, obviously. Or, the pull was done by a secret, in which case we store like some metadata about the secret plus the hash of the credentials inside of the secret. And one thing that is coming up soon is we will be also caching a new way of image pools, which are done by using a service account token. All right, so this is what the image pool intent looks like. You can see a huge slide very few lines. There's pretty much nothing except for the image in there, right? And so this is the file. We really don't know any other information than just like we wanted to pull this image. All right, well, I guess I'll just write it to the file system and see what happens. The image pulled record, however, is much more difficult in its structure. You can see that there is something called last updated time, which is actually used at garbage collected time because we don't want to keep old records. But I didn't even mention that because that's a whole another topic. We are storing the image ref, which is just like some kind of a string which we get from a container runtime interface. And that's how we are able to identify the image in the system. We've got some, and this is the interesting part, which is the credential mapping, right? Because apparently, like one reference from CRI can actually reference multiple like image names, which are underneath the same thing, but yeah, apparently different names. So like for each of the names of the images, we are storing like the information about how the image was pulled. And currently, you can see either it was pulled with a Kubernetes secret or with some kind of credentials which are not accessible, right? And whenever a request for image pool comes, we actually check all of our records for the image of the reference. We go through the image pool secret references, which we've got here, and we check for similarities. Like, was the same secret used as before, even though it may have different credentials now, the credentials properly rotated, and it's fine. Like, we know that this very same secret was used before to pull the image, so you can access the image, right? If you don't have any information about the image being pulled before, well, you have to go and try to pull the image again, so that you know whether you're authenticated or not. And then we would eventually write a record about the image being pulled properly. And so that's what we've got. We also store the credential hash, so that if there are like multiple secrets inside of the cluster which have the same credentials, you also like don't need to go all the way to the container registry, which is what we wanted, right? Originally, we don't want every request for an existing image on node to be going to the container registry. We just want those that we don't know we don't know the credentials that they are providing. All right, I've got a little demo here. I'll make the screen a little bigger so you can see it. How much time do we have? Okay. We got enough time. I'll show you just 2 minutes so that we've got some time for questions as well. So you can see on the left side, is it left side? No, on the right side, there's the old image configuration. On the left side is a Kubernetes running with this configuration that we've got here. There's we basically said never verify pre-pulled images. And that's it, right? Here I'm creating a namespace, and inside of namespace I'm creating a pod. As you can see, it doesn't actually specify any pull secrets anywhere, right, in the manifest. And so, as you might expect, even like both in the old and new version, these just fail because like, I cannot, as you can see, like nobody can actually access the image, right? So that's all good. That's as expected. Now, we deleted pod because it's just there. What we do next is we actually create the secret containing the pull secret required to pull the image properly, and we specify it here in the pod manifest, both in the old and the new Kubernetes cluster. We create that pod, and as would be quite natural, the pod would be now happily running, which it is, right? So that's good. So what happens now when we try to run the pod from before with the if not present image pull policy, but not specifying any secret? So we did that. And we will check what happened. Hopefully. Ah, there we go. And as you can see, with the old in the old Kubernetes cluster, the new pod is just running happily because it was able to access the image. But in the new case, no, it isn't. Right? It again failed on the authorization of at the image registry. And I think that's this is just with a different image pool policy. Never will just fail right away. You can see that, and I will stop the demo after that. Yeah, never also broken. Well, working properly and running happily in the old configuration, which is insecure. All right. So we're nearing end of the presentation. If you are interested about it, these are some links. I actually already uploaded the slides, so you should be able to access them eventually. You should probably also know that Microsoft has an office here in Brno. There's a couple of us coming there. This is some QR code for open positions, in case you're interested. This is me. I'm Standa Láznička. I'm a principal software engineer in Microsoft, and this was my presentation. Thank you for your patience and attention. Do we have any questions? We have one question here. This is going to be a fun one.
Sure. Have you considered fixing the container runtime instead? Because if you fix just kubelet, then other container runtimes users will still be able to use bad images.
Mm-hmm. We were of course considering it, but I don't think that. I think that would take like 5 more years before every implementation was there. When OCI would agree that this is maybe a good idea, and so we just decided to do it this way instead.
Any other questions? So thank you.